Okay, so I wanted to kind of walk you through how to do everything that we've done so far with radicals. So one thing that we started with, and you've been practicing this since pretty much the beginning of the semester, is if I just gave you a radical, let's say you had the radical of 120, then your job would be to find the biggest perfect square factor that can multiply into this and to simplify the radical. And you've been doing that. Remember, your perfect square factors are 1, 4, 9. Actually, 1 doesn't matter to us. It is a perfect square factor, perfect square, but it doesn't matter. Your perfect squares are 4, 9, 16. When you get to the classroom, I actually have a multiplication table at the front that you'll be able to look at, and it has those 25, 36, 49, 64, 81, 81, 100, and then it can go from there. 121 is the next one. So we want to find the biggest perfect square factor of 120. And you don't necessarily have to know the biggest, but you can find one of them that works. So we know that 4 times 30 equals 120. So we could kind of go from there. Actually, I'm probably not going to go through and simplify this radical. You've been practicing with it. You should know how to simplify that. But we will do this because we're going to learn how to do this in terms of dividing. Now, if I had this problem set up where it was 120 times, let's say, the square root of 5. Square root of 120 times the square root of 5 is, well, I can just multiply those together. That's the same as 120 times 5 under the same radical, which becomes the square root of 600. Now, from there, we can figure out what's the biggest perfect square factor to go into that. And then we could simplify from there. And this one, actually, just to show it, we could divide that into 100 times 6, and then it's pretty straightforward. Okay, so you've already practiced with this. I'm just reminding you of things that you should be already somewhat proficient at. Not to say that you're 100% there, but you should already have some idea of the way to approach these problems. So now what we're going to be looking at, what's new today, is that we're going to be dividing. Now we're going to make this a little bit more complex tomorrow. But at the beginning, at least, it's really not that bad. Because just like whenever we have two numbers multiplied together, we can combine them under the same radical. When we have two numbers dividing, we can combine those under the same radical. So this is the same problem. Notice that I just combined it under one radical. I can do 1200 divided by 4, which is just 300. And at this point, I just need to find the biggest perfect square factor of 300. And this is one that, because we just had the square root of 600, square root of 300 is pretty straightforward too. I can quickly realize that that's 100 times 3, and they're both under the radical still. But now notice that whenever I do the square root of 100, that's just 10. 10 times the square root of 3. So I can just plug that in. Delta math is really nice in that it will walk you through the steps if you make a mistake. So let's say you plug in the wrong answer. Let's assume this is the right one. Okay, good. We have it right. So if I look at the steps right here, you can see what's going on. We just divided, and now we found the biggest perfect square factor and turned that into 10 times the square root of 3, and we got our, okay, all good. So let's go through another one of these, and maybe this one won't be as straightforward. I don't know, we'll just see. So I'm gonna go ahead and combine these under the same radical. So 784 divided by 7 gets me, so this is where you're gonna wanna have your calculator. I don't think too many of you are gonna do that one in your head. 112. Okay, so at this point, this is just a straightforward simplify the radical type problem. And we just, let's say in this case, maybe there is a biggest perfect square factor that we could find. In fact, I can think of one right now that can work, but I want to go with, instead of finding the biggest perfect square factor, let's just go with one that we know will work. So let's try 4. 4 is always a safe bet. It's the smallest one. That's just 2 squared. So let's divide this by 4. 112 divided by 4 is 28. So I could split it up this way. Square root of 4 times square root of 28. And I'm showing you this because maybe you find a bigger perfect square factor. And maybe you guys already have jumped to what it should be. But let's say this is where you start. All right. Either way, we can get to the same answer. So the square root of 4 is just 2. Now the square root of 28, is there a perfect square factor of that? I already know that 4 is a perfect square. And if I think about this for a second, I can realize 28 is just 4 times 7. So I can get the perfect, I can get the square root of that, which gives me 2 times 2 times the square root of 7. And so that just becomes 4 square root of 7. And I'm pretty confident there's no perfect square factor of 7, and there's not. All right. The only number that could work is 4, because my other perfect squares are all bigger than 7 anyway. So yeah, going from there. 4 is the only one that could have worked, but it doesn't. All right, so 4 square root of 7. Now let me show you what we could have done. Right here, we might have alternately decided to find out what the biggest perfect square factor is. We could have done 16 times 7 and gotten this done in one step. So that would have been the shorter way of doing it. But notice that even with this other way that we did it, we still get the same answer. So 4 times the square root of 7. I'll submit that. And it was correct. I'll clear all my work. Notice they just did the biggest perfect square factor. They didn't do it with the 4 and then the 4 like we did. So there it is. It's a pretty straightforward process. If you've gotten your head wrapped around everything we've done so far, then this one shouldn't be too much added to it. Tomorrow it's going to get a little bit more complex, and then we're going to add it into what we're actually going to be learning in geometry, because this is all just foundational math skills, right? We need to learn how to work with radicals. But then starting on Monday, we're going to see how are we actually going to use this with shapes, specifically with triangles. And we will talk about that at that point. But at this point, that's all you're going to be doing today. You will have, you'll have to solve 10 problems like this. If you've got the hang of it, you have the opportunity now just to get some practice with it. If you have any questions, feel free to stick around, and I'm more than happy to help answer your questions. If you have questions on anything that I've assigned while I was gone, like Pythagorean theorem or anything else, any questions that you have on the content or anything else, just stick around. But at this point, I'm going to let you guys go to work on that. So have a wonderful day, and I will see you tomorrow.